Here are some examples of what I call boundary problems. Boundary problem has a specific meaning in science, but this is on problems that require decision making and that there is a critical thing you have to recognize. The example was the favorite question people were asking me yesterday was the one about the car trying to get onto the highway. So I'm going to start with a couple of simple ones to give you an idea. Let's say we have a bomber that's flying at 200 meters a second east, and he's in a headwind of 50 kilometers an hour west. Okay? So you're going to have to turn the speed in kilometers an hour to meters a second. That's easy enough. Divide by 3.6. So you're going to get an actual speed of the plane because the wind is slowing him down. And they want to hit a target 800 kilometers away, and they have 6 hours of fuel. Can they reach that target? That should be quite easy for you to figure out if they've got 800 kilometers worth of fuel once you figure out their actual speed and 6 hours flying time. But it could be a suicide mission. The trickier problem would be to decide what is the farthest range this bomber could fly under these conditions, hit a target, and turn around and make it back. And that was actually part of the premise of Dr. Strangelove. The U.S. bomber was losing fuel and had to switch targets in the middle of their bomb run because they could no longer make that bomb run. So try the one, could they make that target 800 kilometers away? And if you feel like harder work, try the second one. The second one would be definitely a grade 12 problem. This is my favorite one, and this would be the only one I might consider putting on a test because there's no acceleration involved. There's no complicated behavior. It's just real simple. The school board is thinking of releasing attendance cheetahs, and they will be outside the school at about 270 meters distance. And any students that are like lolling about, not getting on with it, they release the attendance cheetah. So Ralph tempted the system, and he is 30 meters from the door, and he can run at 10 meters a second. The cheetah, the attendance cheetah, spots Ralph, and it is 270 meters away from the door, but the cheetah can run at 120 kilometers an hour. So once again, there's a kilometer hour to meters per second conversion. But the question is, does Ralph make it into the building before the attendance cheetah disciplines him? This is getting nasty. This one is definitely not testable and would be up there on a grade 12 one. But oddly enough, math teachers seem to be hitting kids with this in grade 10. But they just give them to you as a solution. If I write this equation, VIT plus half AT squared, that's assuming everybody starts from 0 position. We can throw another term in, D naught. They tend to do that in some grade 12 courses and definitely university. Just saying, look, man, the distance he's going to travel is wherever he started, plus any distance due to constant speed, plus any distance due to acceleration. And all of these collapse into just D equals VT if the thing's not accelerating. Let's say I give you the equation of motion of two objects. Object B is traveling at 50 meters a second. So its position at any given moment of time is just 50 meters a second times time. Object A, though, starts 100 meters ahead of object B. So it's got an initial starting distance, but it's sitting still and begins to accelerate at 5 meters per second squared. So this is the equation of object A. This is the equation of object B. Could you tell me that even though A has a head start and it's accelerating, will B ever catch up and pass it, considering it's just moving at 50 meters a second? And I know you sometimes do equations like this in grade not 10. This one is 100% optional. What math teachers do with this is they would give you this instead. They would say, we have this equation of a line or of a curve and this equation of a line. When do they intersect? And they would ask you to plot the two curves or solve for a quadratic. That would be grade 12, not grade 11 unless you're up for the challenge. This is the plot of those two curves. So I just went into a spreadsheet and I plotted those two equations, and I found that yes, in fact, just after the 2-second mark, the red object B, would actually pass object A. But I think you'll recognize that since object A is accelerating, eventually it will catch up again because it's got this term. So that's definitely grade 12 physics at the outer margin of problems we would give you. This one you should be able to do now. Supposedly Galileo dropped rocks off the Leaning Tower of Pisa to demonstrate gravity before Newton. So the Leaning Tower of Pisa is 56 meters high. How long would it take a rock to fall off that tower and strike the ground? Because that's the end of the problem, when it hits the ground. This place is called Perry's Victory and International Peace Memorial in the United States. It's on an island in Middle Lake Erie that I call Drunk Boater Island. I used to go there numerous times on Ranger Exchange from Canada. And this tower is almost a year high, 365 feet, which is 107 meters. And in their little visitor center down here, do you see the people? Well, actually, those are lights. The people, that's like a truck right there, right? This tower is huge. Lightning struck it on the edge, and a big rock came off years ago, went all the way down and hit a woman, and it actually busted her through the pavement because there's a mausoleum underneath, and she was driven into the basement with the tomb of the unknown soldier. For some bizarre reason, they have that rock on display in the visitor center. It's like a big 400 boulder going, "Yep, that's the one that killed the woman," and you just rinse the hair off it and put it in the museum. It's just really kind of a interesting artifact. So if it fell from the 107 high meter tower, how fast did it wallop her? All right, just calculate its falling speed. You can do the time too if you want, but you already did it in the previous problem. So a rather interesting place. And finally, this is now getting a little more advanced. Not really. It's pretty straightforward, and this is a good one to be able to do because it's definitely big time part of grade 12. Canada had an evil genius, Gerald Bull, and he invented a thing called a harp gun, amongst others. It was funded through McGill University in Canada, and US and Canada went 50-50 on this gun. He was trying to shoot things into orbit. His plan was to skip rocketry and fire really well-built satellites into orbit. And this gun fired 16-inch shells, huge. It was the biggest cannon ever invented, really. And it could fire a muzzle velocity of 2,200 meters a second straight up. So using the equations of motion you got, how high could that gun fire? If you launch straight up at 2,200 meters a second and gravity is yanking the velocity off 10 meters per second, how high will the shell fly before it halts? And how long did it take to get up there? Now, unfortunately, Canada and the US government pulled funding for his big giant space cannon. So Gerald Bull went rogue, got mad, went to France and started designing weapons for Saddam Hussein and other things. And there was this belief that he was designing a giant cannon for Saddam Hussein to shell Israel with nukes. So Israel bombed the site and they put out a hit on Gerald Bull, and our evil genius was assassinated. So Canadians are not always that nice. And the prototype of the super cannon is still there outside the hills of Montreal. So there is the space cannon. Its first prototype outside the city of Montreal, and the remnants of the one in Barbados that was firing upwards is still in Barbados. The Canadian one didn't fire upwards. He was just testing it by blowing holes in a mountain. So we have an evil space gun sitting in the hills of Montreal. Anyway, you can give those problems a try, and that would put you at the wizard level of kinematics. But again, if you're struggling with anything else earlier, don't do them. These are just to flex your muscles.